Once you know 3 ways that you can prove triangles congruent, side, angle, side, 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 and hypotenuse leg, then you can actually walk through some of the process of proving those triangles congruent. For example, we have an isosceles triangle, QRS. QRS is an isosceles triangle with QR congruent to SR. So we start every proof by writing the given. QR is congruent to SR because that's something that we were given. And we make the marks, a little tick mark, a little teeny tiny segment on each of those segments shows that those two are congruent to each other. And then it said ray RT bisects QS at point T. That's also given. So we want to go to that ray and see that it bisects QS at point T. Well, what does the word bisect mean? It means it cuts it into 2 equal pieces. So QT has to be congruent to TS. We'll give them 2 marks to show that those two are congruent to each other, but not necessarily to QR and SR. So segment QT is congruent to segment TS because we know what the word bisects means. So currently we have a side congruent to a side and another pair of sides that are congruent. Our 3 options are side angle side, side side side, or hypotenuse leg. We notice that both triangles contain this segment TR, and TR is congruent to itself. Because of a property called reflexive. You look at your reflection in the mirror, you see yourself in the mirror. Segment TR is the same segment that's in both triangles. TR is congruent to TR. And now that we have 3 pairs of sides that are congruent to each other, we can say that triangle QRT is congruent to triangle SRT, which is what we were trying to prove, by side, side, side. The second example says we'd like to be able to use side, side, side on a coordinate plane. So we have a triangle ABC with vertices at 1, 1, 0, 3, and 2, 5. We'll connect the dots, and we have a triangle. Our second triangle, EFG, has vertices at 1, negative 1. F is 2, negative 5. And G is 4, negative 4. So this doesn't look like it is a simple translation. That didn't work so well. Let's try that again. Okay, so there's our 3 points of our triangle. Doesn't look like it's a simple translation. It could be some sort of a rotation or a reflection. But we're going to try to figure out whether triangle ABC is congruent to triangle EFG. So if EBC is congruent to EFG, segment AB would need to be congruent to segment EF based on the way it's been written. AB and EF do not even remotely look like they're the same length. We can find the distance between A and B by using our distance formula or our simplified distance formula, the Pythagorean theorem, a squared plus b squared equals c squared, or the distance is the square root of a squared plus b squared. The distance between 1 and 0 is 1. We'll square that. The distance between 1 and 3 is 2. 2 squared is 4, 1 squared is 1, so the distance between A and B is 5, the square root of 5. E and F have points 1, -1, and 2, -5. The distance between 1 and 2 is 1. So far so good. But the distance between -1 and -5 is 4. So 4 squared is 16 plus 1 is 17. The square root of 17 is certainly not equal to the square root of 5. But maybe they made a mistake when they were writing their congruence statement. So let's check and see. It appears that AC appears to be the longest side of this triangle. We moved from A to C, we moved 1 unit to the right and 4 units up. So AC would have the segment AC would have a length of the square root of 1 squared plus 4 squared, or the square root of 17, as EF did. So this distance is the square root of 17. And EF has a distance that's the square root of 17. But EG has a distance of 1 to 4 is 3. And -1 to -4 is also 3. 3 squared is 9. 9 and 9 is 18. The square root of 18 is the distance between E and G. No other side could have a square root of 18 as its distance. So not only would it have been written incorrectly, but it wouldn't have had the correct distances anyway. So no, triangle ABC is not congruent to triangle EFG because the sides are not congruent to the sides. Corresponding sides are not congruent to corresponding sides. Example 3 asks us to use side angle side to prove that these triangles are congruent. So we start with the given information. It says segment KL is congruent to segment LM. So because we're given this information, we can go and mark segment KL congruent to, might be easier to do it this way on this drawing since it's hard to see. KL is congruent to segment LM. A single mark to show each of those are congruent. Then it says that angle JKL is congruent to angle JLM. JKL, JLM. Let's try that again. It should say angle JLK, congruent to JLM. JLK, JLM. And finally, we have a side that is in both of the triangles. JL is congruent to itself by reflexive. See yourself in the mirror. The segment is congruent to itself by reflexive. And now we have a pair of sides that are congruent to each other, a pair of angles that are congruent to each other, and another pair of sides that's congruent to itself. And because these are the two sides and the angle in between, we can say that these two triangles are congruent by side, angle, side. Finally, in example 4, it says that Craig and his brother are painting a house, and the brothers use ladders that are the same length. So this ladder is the same length as this ladder. If they place their ladders an equal distance away from the house, if that distance away from the house is the same as the other distance away from the house, EC and EF are congruent to each other, as well as the two ladders, AC and DF, being congruent to each other. They want to know, will the ladders reach the same height on the house? So if I have a right triangle, because hopefully the triangle is leaning against a house that is built well and is not leaning, has right angles with the ground. Then we have the suspicion that this could be a hypotenuse leg situation. AC is the hypotenuse of one triangle, and DF is the hypotenuse of the other, the ladders. The hypotenuse is congruent to the hypotenuse because they're the same distance away from the ground, from the house. The leg is congruent to the leg. So these two triangles are congruent. Triangle ABC is congruent to triangle. If I started at A and went to B and to C, it should be named DEF by hypotenuse leg. So the distance between A and B should be equal to the distance between E and D. Because when you get congruent triangles, we get congruent parts, or corresponding parts of congruent triangles are congruent.